All right, welcome back, everyone, to the deep dive. We're going straight to the source today, diving into some fascinating new tech from Meta AI.
Definitely exciting stuff.
Yeah, they just announced this whole Llama 4 family of large language models. We're going to be breaking down their blog post called The Llama 4 Herd, the beginning of a new era of natively multimodal AI innovation. So, as always, we'll be sticking to the technical details, the nuts and bolts.
Yeah, the engineering behind it all, how these models actually work, what they can do.
Exactly. Because we want to go beyond the hype,
Absolutely. Cut through the noise.
to understand what these new models really represent, what they can actually do, how they're different.
Right, the key technical advancements and capabilities.
Yeah. So let's just jump right in, shall we?
Let's do it.
So we've got this Llama 4 herd, as they call it, three main models they're highlighting.
Okay.
First one, Llama 4 Scout.
Right.
It operates with 17 billion active parameters, uses 16 experts. And what's really impressive right off the bat is it can run on a single NVIDIA H100 GPU.
Wow, that is impressive.
Right. For a model of this size and complexity, to fit it onto one GPU, that's a big deal. Makes
Yeah.
it so much more accessible, right?
Absolutely. Efficiency is key, especially when you're talking about models this large.
Exactly. And then there's the context window, a whopping 10 million tokens.
Yeah.
That's industry leading right now.
That is huge. What does that mean, practically speaking, for people building applications?
I mean, think about it. Processing entire books, massive code bases, all in one go.
Wow.
So applications built on Scout could have much more coherent, context-aware responses. Whether it's summarization or code generation, we're talking about a whole new level of capability.
That was just theoretical before, right?
Yeah, pretty much. Now it's real.
And they managed to squeeze all that, the 17 billion parameters and the mixture of experts' architecture onto a single H100. That's some serious engineering.
For sure. And those benchmarks, Scout's outperforming previous Llama models,
Hmm.
competing with Gemma 3, Gemini 2.0, Flashlight, Mistral 3.1. It's a strong baseline model.
Very soft.
Next up, we've got Llama 4 Maverick, also 17 billion active parameters,
Okay.
but this one ramps up the expert count to 128. So a lot more specialized knowledge packed in there. And they were saying it actually beats GPT-4o and Gemini 2.0 Flash on benchmarks.
Interesting.
What I find fascinating is it's getting comparable results to DeepSeek V3 on reasoning and coding, but with fewer active parameters.
So that speaks to its efficiency, right?
Yeah, it's doing more with less, like getting the same horsepower from a smaller engine.
Right, which means lower computational costs, faster inference.
Exactly. And they've even got an experimental chat version that scored 1417 on the El Marina ELO scale. Shows you the potential for conversational applications.
Yeah, they're clearly pushing the boundaries here.
Now, the big one, the real powerhouse, Llama 4 Behemoth.
Okay, let's hear about this behemoth.
This one scales up to 288 billion active parameters.
Wow.
16 experts. Meta's saying this is their most powerful model yet.
Pushing the limits.
Yeah, they're claiming it's one of the smartest LLMs out there.
Bold claim.
I know, right? But they're reporting superior performance compared to GPT 4.5, Claude Sonnet 3.7, Gemini 2.0 Pro, especially on those tough STEM benchmarks.
STEM benchmarks, those are really challenging.
Oh yeah, they're designed to test those higher level reasoning and problem-solving abilities. And get this, it's still training.
Digital training.
That's what they're saying. Imagine what it'll be capable of when it's fully baked.
A model of that scale, nearly 300 billion active parameters, the computational resources you need for that, the data sets, it's mind-boggling.
I know, and think about the potential for scientific discovery, for tackling complex problems that were just out of reach before.
Absolutely. And you mentioned it serves as a teacher model for the other Llama 4 variants.
Yeah, particularly Maverick. They're using this behemoth to transfer knowledge to the smaller models. We'll get into the details of that later.
Looking forward to that.
Now, one of the really big shifts here with Llama 4, both Scout and Maverick, is that they're natively multimodal,
Okay, so they can work with different types of data, not just text.
right? Images, videos, it's all integrated from the ground up. And they're the first in the Llama family to use a mixture of experts architecture.
Bowie, that's a pretty big change.
Yeah, it's like they've completely rethought how these models are structured and how they learn.
So native multimodality, it's like designing a car to be electric from the start instead of trying to convert a gas car later. Everything's just more integrated, more efficient.
Exactly. And speaking of access, Meta's actually making Llama 4 Scout and Maverick available for download right now. You can find them on llama.com and Hugging Face.
That's huge for the research community, for developers.
Oh, yeah. And they're already integrating them into their own products, Meta AI, WhatsApp, Messenger, Instagram Direct, even on the web.
Hmm.
So this isn't just theoretical research, it's real-world application.
Yeah, that's how you get feedback, how you see what these models can really do in the wild. Smart move by Meta.
All right, let's dive into the technical nitty-gritty. First up, that mixture of experts architecture, MoE. It's a mouthful.
It is. Can you break that down for us?
Yeah, I mean, for those of us who don't live and breathe this stuff every day, what's the basic idea here?
Sure, think of it like a giant library, right? With experts on every subject imaginable.
Okay, I'm following.
You wouldn't ask every single expert every question. You'd have a librarian direct you to the one who knows the most about that specific topic.
Makes sense.
That's kind of what MoE does. Instead of activating this whole massive neural network for every input, you have these specialized expert subnetworks.
Okay.
And there's a routing system that figures out which experts are best suited to process each piece of information.
So only a fraction of the model is actually active at any given time.
Exactly. Only the parameters that are relevant to that specific input get used.
It's way more efficient computationally
Oh,
speaking.
right. Both in training and in use. When you're training, you can have a much larger model overall without the cost going through the roof.
Because you're not training everything at once.
Exactly. And when you're actually using the model, you get lower latency, less computational expense.
Because you're only using the parts you need.
Precisely.
And they gave some specifics about Maverick, right?
Yeah, 17 billion active parameters, but a total of 400 billion, alternating those dense layers with MoE layers. 128 routed experts plus a shared expert. It's quite the setup.
It is. So how do all those pieces work together?
Well, those dense layers are probably handling the more general processing, while the MoE layers, with all those experts, they can focus on those specific patterns in the data. And that shared expert, I'm guessing it's handling the really fundamental stuff, the kind of processing that applies across all types of input.
So everything gets routed through that shared expert, but then also to one of those 128 specialists.
Exactly. It's like getting a general overview and then a deep dive from the expert.
And that's how they keep it efficient. Only those active parameters are adding to the computational cost.
Right. And the fact that you can deploy Maverick on a single H100 DGX host or distribute it across multiple systems, that gives developers a lot of flexibility.
Okay, so next up we've got native multimodality and early fusion. These are pretty big concepts.
They are. They're key to how these models work with different types of data, like text and images, together.
Right, so native multimodality, we touched on that. Basically means the model is designed from the start to handle different data types. It's not an afterthought.
Yeah, like it has built-in capabilities to understand both language and visuals.
And then early fusion comes in.
That's how they combine the information from those different sources.
Right, instead of processing everything separately and then trying to merge it later, they're combining it right at the start.
Like blending all the ingredients for a smoothie at once instead of trying to stir them together at the end.
Perfect analogy.
Thanks. So what that means technically is they can do this joint pre-training on massive data sets that include text, images, videos, all mixed together.
And that's how the model learns those really rich connections between different types of information.
Exactly. It starts to understand that the word dog and a picture of a dog, they represent the same concept. It's learning those relationships.
Right, it's getting a much deeper understanding of how the world works, how different concepts are related.
And they're not just throwing everything in a blender blindly. They've got this improved vision encoder based on Metaclip, trained separately with a frozen llama model before being integrated. So they're fine-tuning that visual processing to make sure it's really well aligned with the language capabilities.
That's smart. Okay, moving on to MetaP, it sounds pretty technical.
It is, but it's a really important part of the training process. It's all about those hyperparameters.
Right, hyperparameters.
Yeah, those settings that control how the model learns. Things like the learning rate, initialization scales.
Okay, I'm vaguely familiar with those terms.
Well, finding the optimal settings for those can be really difficult, especially with models this large. It's a lot of trial and error.
I can imagine.
So MetaP seems to be their solution for that. It's a way to more reliably set those critical hyperparameters.
So it takes the guesswork out of it.
In a way, yeah. It makes the training more stable, more efficient, and you get better results in the end.
And they said these hyperparameters are transferable across different model configurations.
Yeah, which is a big deal. It means they can take what they learned from training one model and apply it to others, speeds up the development process.
And helps the open source community too, right?
Absolutely. Gives them a good starting point for fine-tuning those models for specific tasks.
All right, let's talk multilingual pre-training. They really went all out on this one.
They did. Llama 4 was trained on 200 languages.
200.
Yeah, over 100 of those had more than 1 billion tokens each. That's 10 times more multilingual data than Llama 3.
Wow. So this thing's going to be fluent in a lot of languages.
It should be. And not just basic fluency. This kind of training allows the model to pick up on subtle nuances in different languages, to understand idioms, cultural references.
And perform better on tasks that involve multiple languages, like translation or cross-lingual information retrieval.
Exactly. It's a big step towards breaking down language barriers.
So efficient model training. They mentioned using FP8 precision. What's the advantage of that?
FP8. It stands for 8-bit floating point.
Okay.
It's a way to represent numbers using fewer bits. It saves memory, speeds up calculations.
So it's all about efficiency.
Right. And they were able to do this without sacrificing quality, which is impressive. They're pushing the limits of what's possible with low precision training.
And the amount of data they used for pre-training is just staggering. Over 30 trillion tokens. That's more than double what they use for Llama 3.
Yeah, the scale is really something else. This model has been exposed to a vast amount of information.
And that's what gives it its power, right? That's how it learns to generate text, translate languages, write different kinds of creative content.
Exactly. The more data it sees, the more it learns, the better it gets.
And then there's this mid-training phase. What's that all about?
So it seems like after the initial pre-training, they have this intermediate stage where they focus on specific capabilities. They use special data sets, tailor-made training techniques.
To refine certain skills like reasoning or coding.
Right. And to extend the context window, the amount of information the model can handle at once.
And they got some impressive results there, especially with Scout's 10 million token context.
Yeah, that's pushing the boundaries of what's possible.
Okay, so post-training, they've got this whole revamped pipeline. Lightweight SFT, online RL, and then lightweight DPO. Can you walk us through that?
Sure. So this is all about fine-tuning the model, making sure its behavior is aligned with what we want. SFT, supervised fine-tuning, is where they train it on examples of good behavior.
Like, here's a good response, here's a bad response.
Exactly. Then they use reinforcement learning, RL, to further shape its behavior. They reward good outputs, penalize bad ones.
So it learns from its mistakes.
Right. And then DPO, direct preference optimization, that's a newer technique. It's about directly optimizing the model based on preferences without needing a specific reward function.
Okay, so they're using a combination of techniques to fine-tune this model's behavior.
Yeah, and they learned some interesting things along the way. They found that too much SFT and DPO could actually hurt the model's performance.
Really?
Yeah, it could make it too constrained, too afraid to be creative or to explore different solutions.
So they had to adjust their approach.
They did. For Maverick, they cut back on the easy SFT data, used harder prompts for the RL, and even let the model help choose the training data through dynamic filtering.
So they're giving it more freedom to learn, to explore.
Exactly. They're trying to strike that balance between guidance and exploration.
Okay, let's talk about Llama 4 Scout and those long context capabilities. They mentioned IROP.
Yeah, IROP, interleaved attention layers without positional embeddings and inference time temperature scaling. It's a bit of a mouthful.
It is. Break it down for us.
Okay, so the big picture here is that Scout was trained from the start with a 256K context window. That's massive. And IROP is the architecture that makes it work.
So it's all about handling long sequences of information.
Right. Traditional transformer models use positional embeddings to tell the model where each word is in a sequence.
Okay.
But IROP does it differently. It uses these things called rotary position embeddings, or ROP, and it interleaves them with layers that don't have positional embeddings at all.
So it's a more efficient way to encode position information.
Exactly. And the I in IROP also stands for infinite, which is their long-term goal. They want to be able to handle sequences of any length.
That's ambitious.
It is.
Hmm.
And they're using inference time temperature scaling to help with that. It
Right.
allows the model to generalize to sequences even longer than what it was trained on.
Okay, so visual understanding. They train these models on a ton of images and video stills.
They did. They want these models to have a broad visual understanding, to recognize objects, understand actions, even grasp the relationships between different images.
And they trained it on up to 48 images at once, tested it with up to 8. That's a lot of visual information to process.
It is. It means the model can handle more complex visual reasoning tasks, comparing images, identifying patterns, that sort of thing.
And Scout is particularly good at image grounding. What does that mean?
Image grounding is the ability to connect language to specific parts of an image.
Okay.
So if you ask it a question about an image, it can not only understand the question, but it can also pinpoint the exact region in the image that's relevant to the answer.
So it's not just saying, there's a dog in this picture. It's saying the dog is right here in the bottom left corner.
Exactly. It's a very precise understanding of the visual information.
And that's crucial for things like visual question answering, where you need the model to understand both the language and the visual context.
Absolutely.
Finally, let's talk about Behemoth as a teacher model.
Okay, the grandmaster teaching the students.
Yeah. They mentioned co-distillation, which is how they transferred some of Behemoth's knowledge to Maverick.
Right. So in model distillation, you basically have a smaller student model learn from a larger teacher model.
And in this case, Maverick is the student, Behemoth is the teacher.
Exactly. And they've got this special distillation loss function that helps Maverick learn from Behemoth's outputs more effectively. It's like a more sophisticated form of knowledge transfer.
And post-training Behemoth, that must have been a challenge.
Oh, yeah. They had to prune 95% of the SFT data just to manage the sheer scale of it. And their reinforcement learning, they focused it on the really hard prompts, the ones that would push Behemoth to its limits.
It's like they're giving it a crash course in advanced problem solving.
Yeah, they're trying to unlock its full potential. And they had to completely revamp their RL infrastructure to handle a model this big.
They mentioned a tenfold improvement in training efficiency.
Yeah, that's huge. It means they can iterate much faster, experiment with different approaches, push the boundaries further.
It's exciting to see what they'll be able to achieve with this kind of technology.
It really is.
So to wrap up, Meta's really pushing the envelope with Llama 4.
Absolutely.
The MoE architecture, native multimodality, those incredible context links, the efficient training techniques, they're hitting all the key areas of advancement in large language models.
And they're not just keeping it all to themselves. They're releasing these models to the community, integrating them into their own products. It's a big step forward for the field.
I agree. So for all you listeners out there, if you're interested in the future of AI, the future of how we interact with technology, this is something to pay attention to. These advancements in model architecture, training, multimodality, they're going to have a ripple effect throughout the industry.
Definitely. We're just starting to scratch the surface of what's possible with these kinds of models.
Yeah, exactly. More efficient, more capable, able to handle different types of data seamlessly with massive context windows. It's going to change how we build applications, how we solve problems. It's a whole new era of AI.
Couldn't have said it better myself.
Thanks for joining us for this deep dive into the Llama 4 family. We'll be back soon with more fascinating tech breakdowns. Until then, keep exploring.
And keep learning.
Absolutely.